Hello and welcome everyone to our research summer camp for biotechnologies presentation on the topic of fermented myrtle wine enriched with chia seed polysaccharides to increase the immunomodulatory response to COVID-19. Our team comprises of myself, Heramb Podar from India, Mengxiang, Jieqiong, Liuming, and Rongrong Wang from China. So moving on to how I'm going to structure our presentation. As you can see, like first we are going to be like talking about what kind of made us embark on specifying the myrtle wine and how we thought about the different kinds of processes. Then like moving on to how the polysaccharide is going to be extracted from the chia seed. Then a basic fermentation flowchart. Moving on, then we'll have like the chemical analysis, so like the physical and chemical indicators of the wine and the polysaccharide. And then we'll be looking at preservation methods to ensure long shelf life and to have a proper evaluation metric for the functional food. And finally, obviously we need a control and a test group for any scientific product. So we have a preclinical experiment design, which is set up along with any additives which can be added at the end. Um, So starting us off, basically, what exactly is fruit wine? To start us have a basic question. So fruit wines are basically made by fermentation of yeast into alcohol, and they contain like largely the flavor of fruit and alcohol. So you can see the pathway on the in the picture where you have yeast using glucose to form pyruvate through the glycolysis pathway, and the pyruvate will continue and go on to form ethanol. So you can see the ethanol here, and then you have like your wines, and these are like some of the yeast specimens which you can see. So our team kind of started thinking about here we have polysaccharides, which might be a very good way to enrich the immune system's response to COVID-19. But how should we get this polysaccharide from? So chia seeds are already well-known product, which is known as a superfood, primarily in China. And the chia nutlets belong to the Lamiaceae family, as you can see. And they are obviously native to Mexico and Guatemala. So the addition of the polysaccharide in the wine can improve the quality of the wine. And the basic technique for extraction here, which we're using, is a supercritical cold solvent and then a cold pressing for extracting the mucilage from chia seed based on a low temperature and based on a proper mechanical process. So we would like dry the mucilage by freeze drying, and you have the extraction of mucilage, which can be done directly from the whole or ground seed. Yeah, so basically, elaborating on the specific mucilage extraction, you can have optimum conditions like using alkaline pH adjustments, urea or salt addition. You have elevated temperatures, which can be good to increase the yield. That can be used to optimize the extraction of the gel, and the yield here is typically somewhere in the range of 5 to 7%. So that when the chia seeds are like typically placed in water, they exclude this sticky substance called a mucilage, and this sticks to the seed, and you have to first like remove the seed, and this is where you'll get the initial polysaccharides from. This can be done at a pH of 7.4, so like slightly alkaline as I mentioned, with 6 normal urea for about like 7 hours, and the yield as I mentioned is like about 5%. So you can see the basic like flow chart here is you are first like hydrating the seeds to make sure that like you get the initial mucilage. Then you are extracting the mucilage because it tends to stick to the seed because it is inherently having that gum-like, rubber-like texture. And then you are like moving on to recover your polysaccharide, which is going to be the active ingredient for the functional food. Okay, and now that we have like our basic polysaccharide source, the idea here is how can we make sure that it survives inside whatever functional food we would be picking, which is in our case wine. So the basic technique used typically in such situations is encapsulation. So chitosan is a very prominent encapsulating material which we had to decide on. And we proposed to use the spray drying method, keeping the core materials we had in mind. So like you have the polysaccharide, you have the chitosan, which is going to be forming the external layer, so like the external wall, and you have like basic ways to measure and like metrics to keep in mind while carrying out this spray drying method. So you want to measure the size of the capsule. You want to make sure that it is palatable in the mouth. It is not beyond a certain range. So like the size of the capsule should be less than 100 micrometers across. Otherwise, uh, it will be very detectable on the tongue and it will have a very unpleasant feeling, right? Then you want to also make sure that this process of spray drying itself is efficient enough, and we also want to make sure that you're characterizing this encapsulation product and its morphology, and making sure that it is safe for human consumption, and characterizing it properly by FESEM methods to observe the microstructure and the detection of microcapsule particle size to make sure that things are palatable. So you can see here that you have multi-core double encapsulated different kinds of wall materials which are typically used for encapsulation. In our case, the safety of clarification operation seems to be like rather good. The optimal dosage seems to be 0.04 grams per liter, and the temperature is about 20 degrees Celsius for this entire process. Okay. Moving on. So you have like what is the basic flowchart for making the wine. Now that we have the additive or the active product which we want to put in our functional food, what is the main kind of way of making the wine itself? So typically, wine is made from like taking mature fruit. Usually they are grapes. You clean and crush the grapes, and you do a bit of hydrolysis on them, and then you add like a pectinase, which is an enzyme to make sure that this the kinetics of the reaction are sped up, and then you give the accessibility to a certain amount of yeast. Interestingly enough, we have like SO2, which is also added sometimes at this stage. So like sulfide compounds tend to be very useful for frothing and making sure that the sugar in the wine does not settle down just at the bottom. So like they inhibit the growth of harmful microorganisms also, and they have clarifying effect like already mentioned, and they have like an antioxidant property in itself. Also, sulfides tend to lock down the fermentation process, and they're used in tandem with another compound called potassium sorbate. So potassium sorbate is used with sulfides. This compound called geraniol may develop, and that is in itself helps the wine to enter a pre-fermentation stage, and also like kills off some of the unwanted bacteria in the wine making process. We have to be very, very careful about the kind of bacteria we want living in our wine, because we don't want to kill off every one of them, since a lot of them are good bacteria, good yeast, which help the fermentation process. But we also don't want the product to be harmful to human beings, obviously. Then you will separate the scum, which tends to come up on the surface of the wine as froths. And then post fermentation, you would typically like keep the wine in a proper vat, in a proper preservation scenario, where we will talk about this obviously later as well with our product. And then you typically get the fruit wine product. This is the usual flowchart for making the normal fruit wine. Okay, now that we have like our fruit wine and we have like the polysaccharide, the basic thing is we have to run a proper analysis on a chemical level to make sure that all of the things in the wine are like, in terms of sugar content or in terms of alcohol or acid content, are like within the prescribed limits. So we have proposed like different quantitative and qualitative methods. The most prominent probably being like neutral sugar content can be measured by the phenol sulfuric acid method. You can also have different types of spectroscopy which can be run, so which are largely like qualitative methods like infrared spectral, or like just to determine the monosaccharide composition. In terms of like the polysaccharide itself, you also want to make sure that the molecular weight is in the proper range. So you have the high performance gel method, which is the quantitative method to determine that. Moving on to the wine itself, very much interestingly, we used a direct titration method to measure the sugar content, the reducing sugar content and the total sugar content inside the wine. And then you can use gas chromatography to measure the alcohol content, and different methods can be used, such as gas chromatography again for methanol content, and to measure the sulfur dioxide content we can have the direct adometric method. So the basic point we are trying to establish here is all of these are like very well-known chemical analysis methods which need to be performed on said product before this product goes further into production. And we can have like all the checks and balances, and you can obviously see the references we went through at the bottom of the slide. So yeah, so moving on. So this is, I think, probably the most important part of this entire cycle, given that once you have the wine, once you have the polysaccharide, and once you have put the polysaccharide into the wine, you want to make sure that it is able to withstand a long amount of time, especially with wines, because uh, typically in the wine markets, a much more aged wine is considered to be much more tasty and is hence like priced at a much higher rate. So you want to make sure that the encapsulation is done in a way that the polysaccharide can withstand this long time frame. So some of the preservation methods we are like looking for is avoiding light inside your storage vats, having the bottles lie down, an ideal temperature in the room being 10 to 14 degrees Celsius, and an ideal humidity of about 70%. In terms of like the reactions which we are trying to monitor for preservation, there are a series of complex and slow chemical changes which happen between the original component of the wine and maybe the oak barrel which the wine is stored in. So typically these are three reactions. This is oxidation reaction, the esterification reaction which will happen in the wine, and a polymerization runaway reaction. So typically people tend to use antioxidant compounds, largely glutathione or sulfur dioxide, so that the formation of the sotolon and the wine aging is like properly mitigated, and reducing the dissolved oxygen is also like obviously a very key metric here. Apart from that, our team also worked on what can be the best way to package this material, given that the thing inside the bottle is safe and is properly preserved. So we want to have proper bacterial antagonists, so that the bottles covers are themselves free from any sort of bacterial contamination. We want to have edible coating so that we have environmental friendliness being promoted, and we have nano packaging being proposed. And in terms of like a overall sensory assessment, which is a very important thing in the markets, we have given an equal weightage to flavor, consistency of the wine, the aroma which might be emanating from the wine, and the color of the wine. So the idea here is that all of these factors play into each other. When a consumer would be seeing a wine, there might be first impressions in terms of the color being pleasing to the eye, which might result in that in the wine being much more attractive. Then obviously in terms of flavor and in terms of aroma, these two are known to be part of a cycle which makes human beings have a sensation of taste. So like olfactory senses such as smelling are obviously a very, very big part of us tasting any kind of food, and we obviously want the wine to still be tasty even after adding the polysaccharide. And as we mentioned before, with the encapsulation process, the texture of the wine should be palatable. It should not have like very, very high amount of like very big or very high amount of encapsulated materials or any kinds of fruit remnants in the wine. We want this to be a very smooth experience for the consumers, that this wine is better promoted in markets. Other general guidelines which come to mind here are using potentially smaller bottles is much more economical. Storing opened wine bottles in an upright position is very beneficial because it reduces the surface area exposed to oxygen. And obviously, like wine preservatives can be used. So you have your tannins, you have your sugars, you have your sulfites. Sometimes people also use vacuum pumps, that is for hermetic sealing of the wine, which is a much more advanced method and a much more costly method. So on the basis of this, like while doing our literature review, our team came across many analytical studies, many results which were proposed, And very much interestingly, one of them was using NMR spectroscopy and to measure absorption spectra of wines um, and their shift in color during aging. So here you can see on the left, you have this graph which has the wine at different ages. So like the number one is like a 1-year-old wine, number two is a 10-year-old wine, and number three is a 5-decade-old wine. So you can see that how the color would progress, and this is monitored very precisely using the absorbance detection methods. And another rather interesting factor here is the intensity of the fragrance can also be plotted similarly against not only different ages of wines, but also different types of wines. So you have your nouveau style wine, you have your standard quality red wine, you have your premium quality red wine, and all of those are like plotted as an intensity or density of fragrance is plotted against the years of aging you have. So these kinds of analysis methods can also be carried out in the long term to make sure that you have a proper safety assessment and a proper quality assessment of the wine. Okay, so what kind of additives can we add to prolong the life of the wine after storing it in a vat or after setting up the entire process for the polysaccharide? So like you already mentioned, tannins are very popular preservatives. Sulfites are very popular preservatives to be used. Apart from that, you have your anthocyanins, which are flavonoids, which also are extremely good antioxidant for the body. So they also help boost the immune system's response to COVID-19. So the basic point here is polysaccharides and any kind of additive we are making or we are adding to the wine, they should aid the immune system in fighting off and staving off COVID-19. So polysaccharides are obviously like an energy-rich source. They have like many benefits in terms of helping the immune system produce like macrophages, repel any kind of respiratory infections which might be coming up. And you can also like potentially have anthocyanins, which are added as additives later on, but are also helping against the fight with COVID-19. So this is like a doubly good additive system in the wine. And then you obviously have your quercetin. It has some very good anti-inflammatory effects, and it also has like antiviral properties. And you have your resveratrol, which is very good at inhibiting the growth of cancer cells and again like resisting cardiovascular diseases. So the many additives you're trying to add are also aiding in other secondary things, which is very, very beneficial. And finally, and obviously not the least, you have your preclinical experiment design, which needs to be set up to make sure that this wine is safe, and you have a control group and a test group to make sure that what kind of reactions are going on in the body, or to monitor that whether there is any significant change in the immunomodulatory activity of this due to this wine in the body's immune system. So the method we are proposing here is using mice and injecting them via syringe with our functional food, which is the wine, and checking whether there is a significant difference between the control group and the test group in terms of immunomodulatory effects. So in this regard, we can have measurements of TNF alpha, ROS, NO, various kinds of intestinal flora, IL-1 beta. So all of these can be very proper, streamlined ways of measuring and acting as metrics to make sure that our wine is actually feasible and it is safe and it is working. Okay, so now we are pretty much like wrapping up, and just to kind of touch on the very ethos of research at the end of the day, or putting forward any product, is making sure that people can build on top of it and making sure that it can be bettered in the future. So on the left, you can obviously see the entire flow chart which we have proposed for the functional food, the wine infused with polysaccharides. The entire production scheme is there. So you have your cold pressing and drying of chia seeds, which will get you the omega-3 fatty acids, which will get you the polysaccharides. You can use this polysaccharides obviously to encapsulate with the chitosan layer. You can use the omega-3 fatty acids to enrich the encapsulated layer. So you have the dual layer, like I was talking about earlier. So you have the polysaccharide and you have the omega-3 fatty acid on top of it, which is made by spray drying, which you can then preserve by a fermentation, proper storage in a vat, putting chemical additives in, preferably flavonoids because they have antioxidant effects. You're getting your final product, which you can run proper preclinical testing through mice, do a chemical analysis, measure the color as the absorbance versus lambda graphs which we showed earlier, and have a proper storage mechanism. In terms of like a future steps, the biggest thing missing here probably is making sure that this functional food complies with the laws of different countries. So obviously different governments, different regions of the world have different kinds of regulations, different kinds of guidelines as to how things should be carried out. And compliance with these authorities is very necessary. And if anything in this flowchart happens to be against the guidelines of a certain country or a certain law, then obviously an appropriate substitute needs to be found. Using techniques such as NMR and gas chromatography, we can further find optimal storage conditions for our wine with the polysaccharide in it. Jumping off the very fabulous review papers we came across where the color of wine with the absorbance graph was measured. A proper selection of bacteria culture and yeast culture for our wine is very essential to promote like an optimal sweetening, to make sure that there are no side reactions between the bacteria culture we are having and the polysaccharides we are infusing the wine with. And obviously like an appropriate level of antioxidants, a specific flavonoids which can be added to the wine. Maybe there are more such compounds out there lurking which we haven't quite mentioned in this slide, for example. So those can also be properly researched and added to the wine at the end. Okay, yeah. As a closing note, thank you very much for listening to our presentation, for being extremely good hosts. Thank you to the entire team at ITMO. Thank you for the research summer camp in biotechnology 2022. Thank you to the Nanjing University, where my colleagues from China hail from. And yeah, as a parting note, spasiba большое from Russia, Shiji from China, and Dhanyawad from India. Thank you. This is Heramb Podar from the evening group number 4 signing off. Thank you very much.